Hello everyone, welcome to all in this lecture. In this lecture, I am going to discuss center of gravity, how we can calculate center of gravity for the lines. Whether line can be a straight or can be a curve. In the first lecture, I have discussed what is the center of gravity, what is the concept of center of gravity, what is the application of center of gravity. In the second lecture, I have discussed how we can find out the center of gravity for the plane figures like rectangle, triangle, semicircle, an arc of a circle, whatever. In the third lecture, I have discussed what are the method and what are the procedure and how we can calculate the center of gravity for the solid bodies like hemisphere, like other shape of like right circular cone. In this lecture, I'm going to discuss center of gravity of lines. It can be a straight or it can be curved. Okay. Now, in the previous lecture, you have seen that in the case of plane figures, how we are calculating the x bar and y bar. So this was the formula we have. X dash dA divided by integration of dA, right? And y bar integration of y dash with respect to dA integration of dA. Right? So this is the formula that we are using in the case of plane figures. Okay. Now we can calculate the center of gravity for the lines. So what we will do? We can calculate the center of gravity for the line. Maybe it can be straight or it can be curved. So what we will do? We will divide the line into a large number of small lengths. We'll divide a large number. Suppose in this case, total length from A to B, the length of line is L, and this is the shape of curve. Okay, so we have taken this a small length, that is DL. DL means very small length, very small length. Okay, now we can calculate x bar we can calculate x bar. So we will just x dash, we will replace dA by dl, integration of dA. Are you getting a point? Okay. Similarly, for y bar, integration of y dash, replace dA by dl, integration of dl. Where what is the x dash? X dash is the distance of centroid of this dl length. This is a small length from the y-axis. So in this case, this length we have considered dl. Okay, this we have considered. So distance from the y-axis, it will be x dash. Similarly, in the case of y dash, this is a small length, centroid will be here. Okay, and the centroid will be here, and this distance between centroid of this small length dl from the x-axis, that is y dash. So that is written here in the figure. Okay. So this is the basic method you can calculate, or we can, if the lines are straight, okay, straight line are there. So what we will do? We will just convert this integration into summation. So in this case, x dash will be summation of xi li, where I will go from 1 to n. If we have divided in n number of segment, n number of straight lines, summation of li, I is equal to 1 to n. Similarly, we can write for y dash, summation of I 1 to n, yi li divided by summation of I is equal to 1 to n li, where what is x1, x1, x2, x3? These are the distance of centroid from the segment, like first segment, second segment from the y-axis. Similarly, for y1, y2, y3, these are the distance of centroid of that segment from the x-axis. Are you getting my point? So we have to divide when the number of straight line are combined. A line is combined with the number of straight line. So we'll divide each line that will be straight, and then we will take x1, x2, L1, L2, their length, and similarly y1, y2 in their length. Are you getting my point? Okay. So this one. So when we will apply this formula when the lines are in the straight, lines are straight, then the lines will curve in shape in the arc of a circle, whatever. So in this case, we will apply this integration formula, right? See, I'm going to calculate center of gravity of a line that is a quarter of circle, 1/4 of a circle. So line are given, and we are assuming that centroid will be somewhere here. Just I'm taking assumption. This is a centroid, right? Okay. So now we are going to find what will be the distance, what will be the x dash, and no. Okay. Suppose centroid will be here somewhere. Centroid will be here. Okay. So we have to calculate what is the x bar and what is the y bar. You have to calculate x bar, y bar. So now we have the formula to calculate x bar. What is that? Integration of x dash dl divided by integration of dl. Right. So we have to take one small length. So I am taking some small length, suppose dl, suppose this length, because this total length, capital L, total length is capital L, okay? And I'm taking this small length here, I'm considering this a small length on this arc of a circle, that is dl. So this is dl, right? Okay. Now, so d for the dl, so centroid will be here for the small length, and that distance of the centroid to the y-axis, that is x dash, and from the x-axis, that is y dash, right? Okay. So how we are taking like this? So I am drawing a line, and the radius of the circle is capital R. This will be also capital R. So this is also radius, so this will be also capital R, right? Now, okay. See, and I'm taking this angle is theta. Angle is theta. So if I am going to take a small length, so change of angle will occur at the center. The center will be small angle, very small angle. So that we can write like this. So this is the L, and this angle will be small theta that I'm writing by d theta. So this is nothing but this is like that. For the dl theta, dl small theta, the length will change, that we call small length dl. So by changing the d theta, length will change dl. Okay. Now from this figure we can write total length. So this is the, what is the total length of this in the case of circle? So that is 2 pi r. Total length in the case of circle, that is 2 pi r. But this is the quarter, means 1 by 4. The length will be 1 by 4. So 1 by 4 of length of circle. Okay, if line will follow the circle, then length will be 2 pi r. So we can write pi r divided by 2. So that is the total length. Okay. And this distance is r here, right? Because this is the radius. So what we can write dl is equal to? We can write d is equal to r d theta. There is a formula. If change into length, change in length, change in the angle at the centroid, at the center, that is ratio of length of arc divided by the radius, means d theta dl by r. So this is formula. So by using this formula, I'm writing dl is equal to r d theta. It means d length, dl length, that is a small length of this arc, is occurred due to the change in a small angle, that is t theta, at the center. So we can write dl is equal to r d theta. Now, what we can write x dash and y dash. See, this is the theta, right? And this is the r. And this we can say, if you're drawing a triangle, so this is the right angle triangle, you can say. So r sine theta, so y dash will become a r sine theta, that is y dash. And if we'll take this length, this will become an r cos theta, and that is equal to x dash. So we can write here x dash is equal to r cos theta. So now we have the x dash, we have the y dash, we have the delta L. Okay, now we can apply the formula. So to cover this length, see, to cover this length, like I'm writing here, we have to cover this arc of a length. So if the theta will be here, if the line, if we are taking the delta L will be here, so in this case, theta will be 0. When we cover here, it will go from here to here. So this up to here, theta will be 90 degree. Or we can say in the terms of radian, pi by 2, right? So means means by doing the integration, the upper limit will be pi by 2 and lower limit will be theta. So by taking this lower limit of upper limit, so we can get the quarter of circle. Now, okay. Now we can use this formula. First we will calculate x bar, then we will calculate y bar. What x dash we have? Just put in the single variation theta. So x dash we have r cos theta into delta L. What is delta L? dl, that is r theta. See here, r theta. So into r d theta, r d theta divided by c. Here it is the integration, here it is the differentiation. It will cancel, it will become total length. Total length of this quarter of circle lines of this quarter of circle. Now, integration, what we are getting, r square cos theta d theta divided by total length. Total length we have calculated pi r by 2. Just put this value pi r by 2. Now, this is r square is constant. We can take the outside of integration. So it will become r square integration cos theta d theta divided by pi r by 2. Now, what is the integration of cos theta? So I'm writing one formula. Just note down. Integration of cos theta with respect to theta is equal to sine theta plus constant, right? This is the integration. So by putting the lower limit, upper limit, c will be cancelled out, right? So this is the integration. You can remember this formula. So I'm applying this formula here. R square integration sine theta. Now, what is the limit? Lower limit will be 0. Upper limit will be pi by pi by 2, that is 90 degree. Divide by pi r by 2. R will cancel, so it will become 2r divided by pi. Right? Now, sine pi by 2 minus sine 0. What is sine 0? Become 0. Sine pi by 2, it will become 1. So we are getting 2r by pi. That is x dash. Okay? 2r by pi. Similarly, you can calculate y bar also. Let me show you. Here we get r y dash, that is r. Here it was dl. This is r. This is small d theta. This is theta. So this is r sine theta. Okay, and y dash is total length, we get pi r by 2. Right. Now y bar is equal to integration of y dash dl divided by dl. Now put the value of y dash, that is r sine theta dl, that is r d theta, divided by integration, differentiation, you will cancel, we can write L. So we can write r square sine theta d theta divided by pi r by 2. I'm putting the value of capital L, length of this quarter of circle. Similarly, r square is constant, so we can take outside integration. So r square integration of sine theta d theta. Again, there is a formula of integration. I'm using this formula. Just note it down. Integration of sine theta with respect to theta is equal to minus cos theta plus c. C is the constant here. So by putting the lower limit, minor limit, this will be cancelled out. So r square minus cos theta. What will the lower limit? That is 0, upper limit pi by 2 divide by pi r by 2. So by simplifying, we can write 2r divided by pi minus cos pi by 2 minus cos 0. What is minus cos pi by 2? What is minus cos pi by 2? And here the plus. So cos 0 is 1, and this will be pi by 2 is 90 degree. So this will be 0. So what we are getting 2r divided by pi into 0 minus plus, here minus minus will plus 1. Cos 0 is 1. So we are getting 2r by pi. Right? That is pi. Now, suppose centroid will be here in this case. So we got x bar and y bar. Both are x bar is equal to y bar, that is 2r by pi. If this is a radius is capital R. Right. So what will be this centroid distance from the center? So that we can also calculate by using the Pythagoras theorem. So we can write, suppose this length is we are just some value. Suppose this length is a, right? So we can write x square using x dash square to y dash square. So what we are getting 2r pi whole square plus 2r pi. So by doing this, we will get 2r pi into root 2. Means we are getting 2 root 2 r divided by pi. Right? No, is a is equal to, right? So we are getting a is equal to this. Why I'm writing, we will see in the coming slide. So just remember this distance from the O each like 2 root 2 r divided by 5. Now we can calculate for the semicircle also, right? See, it is very easy. Like in this case, also take here r, take a small change, that is d theta. So length will be shell dl, very small length. This will be y dash, that will be r sine theta. Here x dash will be r cos theta, right? In this case, total length that we are getting here, half of length of circle. So half of, what is the length of circle? 2 into 2 pi r. So we are getting pi r, total length, right? We can apply this formula. Due to symmetry, we can say in this case that x bar will be 0 because center of gravity will be lie somewhere here on the line. Due to symmetry, we can say, right? But we can calculate also. If you want to, we should show by deriving it should become 0. So it will come 0 also. So that I will show. So first calculate y, y bar. This is y bar, right? Okay. So we have formula y bar, y dash dl divided by integration of dl. We have the y dash r sine theta. dl we can write r d theta. Okay. Like previously we have written, divide by length, integration difference length. Okay. Now r square we can take outside, it will get integration sine theta d theta divided by length, that is pi r. Okay. Now we can do the integration. So by dividing r divided by pi, see cos theta, integration of sine theta will be cos theta. What is the limit? So when length will be here dl, so here the theta will come 0. When by moving here like this, when d is rotating to here, so this here theta will become pi. Theta will be pi. So upper limit will be pi, lower limit will be 0. By putting this limits, lower limit, upper limit, it will cover the semicircle. It will make the arc of circle, semicircle. So we can write r divided by. See, here it's coming minus. Integration of sine theta will be minus of cos theta. Sorry, minus of cos theta. So minus of cos pi minus of cos 0. Minus of cos pi, this is basically minus 1 and this is basically 1. So what we are getting, r divided by pi into minus, so it will become plus. Here also minus into minus, it will become plus 1. So we can say 2r by pi. So in this case, we are getting y bar, that is 2r by pi. Now I am saying that x bar you will get 0. So that I will show also how we are getting 0. Let me show here only. Just put the value of x using this formula, x bar integration of x dash dl divided by integration of dl, right? X dash, put the value of r cos theta dr d theta divided by length. R square we can take outside, integration of cos theta d theta divided by r, that is pi. By simplifying, we can write r divided by pi, integration of cos theta, that is sine theta. What is the lower limit? That is 0. What is the upper limit? That is pi. Right? See, r divided by pi. Sine pi, upper limit minus lower limit, that is sine 0. We know sine 0 is 0. We know sine pi is 0. Right? So 0 minus 0, it will come 0. So it will become 0. So if seen, we are getting x bar is 0. right? So in this case, x bar is 0, y bar is 2r by pi. Are you getting my point? Okay. Now, this is very important. By calculating of this, you can calculate for any shape of arc circle, right? So this is the arc of a circle which makes an angle. Okay, this is nothing. This is alpha. This angle is alpha. Okay. This is x-axis. This is y-axis, right? Alpha we can say semi-angle of this arc of a circle. Semi-angle means half of this angle, total angle. So due to symmetry about the x-axis, we can say centroid will be lie on this x-axis. So by knowing this, by seeing this figure, we can write x bar will be 0 because center of gravity will be lie somewhere here on the x-axis, right? Then now we have to calculate what will be the x bar. What will be the distance of center of gravity from the y-axis? So we have to calculate x bar. Again, we do the same procedure. Take an angle theta here. Do the small change in the theta, that is d theta. So length of change will occur dl. This will be the radius of r. Radius of r. So we can write dl is equal to r d theta, right? And centroid will be somewhere here for this small length. So what we can write y dash, we can write r sine theta, and similarly we can write x dash, this length, that is r cos theta. Okay, so what we can write total length of this arc. So total length we can write, what we can write. So there is a formula, whatever the angle at the center, that is 2 angle. Total angle will be 2 alpha, because this is half of angle is alpha, half of angle is alpha. So total 2 alpha divided by 2 pi is the formula. 2 pi, this total angle at the center, 2 pi, or we can say in the degree 360 degree, into total length of this circle, that is 2 pi r, right? So we have this formula. So this will be cancelled out. So total length will come 2 alpha r. Okay, 2 alpha total length. Now we can apply the formula here. We are going to calculate x bar. So x dash dl divided by integration of dl. Put the value of x dash, that is r cos theta, into dl, that is r d theta, integration. So integration difference, it will be total length, that is l. R into I, it will become r square. We can take the outside of integration, because that is constant, so it will become cos theta into d theta, divided by length, that is 2 alpha r, right? Integration of cos theta, what is that? Sin theta. What will the upper limit, lower limit? See, we will follow the convention, sign convention of this angle. So if sine, see, if alpha will be, I'm going from here to here. So if suppose length is here, this is the lower limit, length is here. So what will be the angle? So this alpha is here, means angle is alpha means here. Okay, alpha is 0 means you are here. Alpha is here means this angle will be minus alpha. We have to go here to here. So here angle will be plus alpha, positive. Means we are setting the limit, lower limit minus alpha, upper limit is plus alpha. Means it will cover like here to here. So this is minus alpha, this is plus alpha. So it will cover the whole length, right? Okay, so minus alpha to plus alpha. Divide by 2 alpha r. R will cancel, so we can write r divided by 2 alpha into sine plus alpha minus sine minus alpha. Now, again we have one formula for this. I'm writing sine minus theta is minus sine theta. We can take this minus outside, so sine minus theta will become minus of sine theta, negative of sine theta. So now we can write r divided by 2 alpha sine alpha minus, this minus alpha will come outside, so we can write minus sine alpha. R divided by 2 alpha into sine alpha plus sine alpha. This minus minus will be plus. So similar, finally we can write r 2 sine alpha divided by 2 alpha. 2 will cancel. So finally we are getting, I'm writing here, okay. Finally we are getting x bar, that is r sine alpha divided by alpha. Sine r sine alpha divided by alpha, that is x bar. You can calculate y bar also, you will get the 0. You will get the 0. You can try, okay. So now for this we are getting somewhere here, this is a g, we are getting this x bar, that is we are getting r sine alpha, where the r is this radius of circle and radius of this arc circle, and where alpha is the semi angle of this much only, okay, alpha. So we are getting x bar r sine alpha divided alpha. Now if alpha will be 45 degree, if alpha will be 90 degree, what is my point? Suppose this is the problem we have. Suppose alpha we are taking 90 degree. So alpha we are taking 90 degree means this is the alpha. So minus alpha will be also minus 90 degree. So it will cover this y x. Means this arc of a circle will become a semicircle. Arc of a semicircle. And we have calculated centroid for this is 2r by pi. So we'll check that is correct or not. Like this, from we can calculate from in this relation also. So see, x bar r sine alpha divided by alpha. So alpha we have to take 90 degree, means pi by 2. So sine r sine pi by 2 divided by pi by 2. Sine pi by 2 is equal to 1. So it will come r into 1 divided by pi by 2. So it will become 2r by pi. So by putting this value of alpha, we can calculate center of gravity for the semicircle, right? So this will be the 2r divided by pi. Now I am taking alpha is equal to pi by 4, means 45 degree. What I will get? See, this is 45 alpha, this is also alpha, 45, so it will become 90 degree. Centroid will be somewhere here. So we have seen in this case, when we are solving for the quarter, we have seen this case from the O. So we have seen this length that is A, we have considered 2 root 2 pi r by pi. Similarly, we have seen like this, okay? So we can check. So this length in this case will be x bar. Are you getting my point? X bar. We will see also. So we have using this formula, what we have calculated X bar is equal to R sine alpha divided by alpha. Put the value of alpha is equal to pi by 4. So R sine pi by 4 is equal to divided by pi by 4. Sine pi by 4, what is that? It is 1 by root 2. Sine pi by 4 is 1 by root 2. If you don't know all these things, just remember some of the trigonometric relation and their value. So R into 1 by root 2 divided by pi by 4. By simplifying, it will come 4 R divided by pi root 2. Again, you can simplify, it will come 2 root 2 divided by pi. So you can see by using this relation also we are getting, and when we have calculated this, in this case, y bar, x bar, by taking the root under of this x by a square plus y bar a square, we are getting this value 2 root 2 r divided by pi. So in this case also we are getting the same value. Are you getting a point? Okay. Now, for the straight line, we have shown some formula like x bar. For a straight line, it will become like summation of y is equal to n xi li divided by summation of I is equal to 1 to n li. Or we can write like this also, x1 L1 plus x2 L2 plus x3 L3 and so on. Divide by L1 plus L2 plus L3 and so on. See, so this is the straight line. So I am taking this axis as a y-axis. So this line I am assuming y, and this one I am assuming x. Okay. Now you can write L1, L2, L3, L4 also, but better I am taking this one of the, like, I'm putting some value. Suppose this length is 200 mm. This length I am taking 150 mm. This length is 200. Okay. So this line is combined of three straight line. So we can use formula. So I'm taking this length. This is length L1. This I am taking L2. This I am taking L3. Similarly, we will take x1, x2, x3. So for this length L1, you can see this centroid will be somewhere here. L8 value. For the straight line, center of gravity will be L by 2, right? So center of gravity for this first line, that will be here. Okay. So you can see x1 will be, in this case, will be 0, right? And y1, what y1? Y1 will be L1 by 2. I get my point. So y1 will be L1 by 2. L1 is 200 divided by 2, 100 mm. Come for the L2. So L2, x, the centroid will be here. So x bar we can write for x2. So x2 will come, distance this to this. So L by 2, L2 by 2, L2 by 2. So 150 by 2, it will come 75 mm. Right? Now come to for this L3, third line. Centroid will be here. So this will become y3. So y3 will come L3 by 2, and 200 divided by 2, it will come 100. And x3 means this length from the y-axis. So x3 will come. What is the distance from here to here? So see, this line is 150 mm, so distance will be 150 mm. Right? So now we have for L1, yeah, for first line we can say first line L1 we have 200 mm, x1 we have 0, y1 we have 100 mm. For the second line, L2 we have 150 mm, x2 we have 75 mm, y2 we have y2 in this case. See, this will be here, so distance will be from the x-axis will be 0. So in this case, y2 will be 0. Now, come for the third line. L3 is what is that? 200 mm. X3 we have 150 mm. Y3 we have what is Y3? 100 mm. Now we can apply the formula to calculate x bar and y bar. So I'm calculating x bar. So that is x1 into L1 plus x2 into L2. So I'm writing directly. I'm putting this value x1. X1. So x1 is 0 into L1. That is 200 plus x2. That is 75 into L2. That is 150 plus x3. That is 150 into L3, that is 200 divided by 11 plus L2 plus L3, 200 plus 150 plus 200. So whatever the value we will get, that will be x1. Similarly, you can calculate just calculate this, what value you are getting. Similarly, we can calculate for y bar. So it will come. I'm writing directly formula of y1 L1 plus y2 L2 plus y3 L3 divided by L1 plus L2 plus L3. So putting the value what you are getting. So we are getting x bar, that is 75 mm. You can calculate, and y bar we are getting 72.72 mm. Okay, so whenever you will see this line is made by the number of a straight line, so you can go for this formula that x bar is equal to summation of x I li, where the I will go from 1 to n, divided by summation of li, where the I will go from 1 to n, right? So we apply this summation formula when the lines are in the straight line. Lines are straight, right? Okay. Now I am deriving one formula for this case. So this is the quarter of a sphere. Okay. So what we can do? This is assume this is capital R. Okay. So I'm taking one small strip, small segment here. Suppose this is y-axis and this is the x-axis, right? So I'm taking y, and this length parallel to the parallel to this x direction. So this length in the direction of y. So this will be dy, and here r at this length will be. I'm taking this length is r. Okay. So what will be this value? So this is also radius of this sphere. So it will become r. So by using the Pythagoras theorem, we can write from here. So this we are getting like this. This is y, this is r, this is capital R. So we can write r square is equal to capital R square minus y square. Okay. Now, and we can write for the dv. What is dv? So that area will be area into dy. What is the area? So this is very important to understand. Okay. See, when you cut this, suppose you cut the hemisphere, you taken the segment in the hemisphere. So this was coming like circle. Now again you are cutting like this. Okay, so this will become the half of circle. This is not a full circle. So this segment will be whatever we are cutting. So when we'll cut and we'll see from the top, so it will be semicircle. It will be look like semicircle. That you have to understand. So semicircle and the radius is r. So we can write the area pi square by 2 into. So this is very important. So I'm going to calculate y bar. Similarly, you can calculate x bar also by taking the segment parallel to the y axis. To calculate the y bar, you have to take the segment parallel to the x axis. Right? Similarly, you can calculate the x bar also, but now I'm showing y bar. So first write the formula for solid body. So integration of y dash dv divided by integration of dv. Now put the value of y dash. So see, segment we have taken this, centroid will be here. So that is distance y from the x-axis. So y dash in this case will be y. dv, we can write pi r square by 2 into dy. Divide by integration difference into v. So it will become. And what will this total capital V? So this is 1 by 4. This is a quarter of sphere. So 1 by 4, what is the formula for a sphere? So 4 pi r cube divided by 3. Okay, so we can write pi r cube by 3. Right? Okay. Now, so put the value of r square, that is this, capital R square minus y square. So y into pi by 2 into r square, that is capital R square minus y square into dy divided by v, that we have pi r cube divided by 3. Now, what is the constant that takes outside? So pi by 2 will be outside into, do the multiplication. So it will come r square into y minus y cube into dy divided by pi r cube divided by 3. So by simplifying, we can get pi will cancel. So we can get 3 by 2 r cube, right? Pi will cancel 3 like this. Now integration r square. So r square will be r square into y. Integration of y will be y square by 2 minus y cube, y 4 by 4. What is the lower limit? So lower limit, when the segment will be here, y will be 0. When the segment will be here, y is equal to capital R. So capital R will be upper limit, 0 will be the lower limit. Right? So we can write 3 by 2 r cube into r square, r to the power 4 by 2 minus r to the power 4 by 4. Right? Okay. So it will come 3 divided by 2 pi q into r 4 to the power 4 by 4 by r to the power 4 by 4. So what we are getting, 3r by 8. That is x bar. That is y bar. If you will calculate, you will get the same value. You will get also x bar is 3r by 8. But in this case, what you have to do, you have to take, I'm showing little bit. Okay, I'm showing just. So you will take to calculate the x bar. we'll take the segment, we'll take the segment like this, parallel to y-axis, and this will be at a distance of x. Length and width of this segment will be dx. Okay, this will be the capital R, this will be the capital R, this will be the x. So you can write x dash in this case will be, this will be the R. So in this case, we can write R is equal to capital R square minus x square, right? In this case also, lower limit will be, x will be 0, and upper limit x will be, this is the lower limit. Next will be this capital R, this will be the upper limit. So by simplifying, you can get x bar in this case also 3R by 8. Okay. These are some references that I've taken to make this lecture. Thank you. In the next lecture, I will discuss center gravity for cut holes. When we know the center gravity for the sphere. But suppose if one cube will cut from this sphere, so what will be the centroid for that rest part? Okay, so that I will discuss in the next lecture. Thank you.